Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. This is continuation of the previous clip, the previous problem. Remember, we had two bodies, and this body is F1 pulling that way, and that body is F2 pulling that way, and we have coordinate systems that we decided to direct this way, and then we received acceleration F2 minus F1 over total mass, and then we received the tension force of the rope that connects those two bodies. And it works very good, and what we started to discuss some extreme cases. For example, we discussed what happens if F2 equals 0. This was first case. F2 equals 0, and this was the previous problem. And we came to conclusions that A equals, if we put 0 here, it would be minus F1 divided over M1 plus M2, and it was the solution from the previous problem, only negative here, but in that case, obviously, when there is only one force F1 and no force F2, everything would be accelerated to the right, and axis is pointing to the left, so obviously acceleration would be negative in that axis. So this has a lot of meaning. Another thing that we discussed, that if F2, for example, bigger than F1, then the net force is F2 minus F1. This is the net force that is acting on the system of two masses together, and those two masses accelerating with the same acceleration. And of course, from this, if we send this bracket to the bottom, we will get this formula. So again, very good physical meaning. We also discussed what happens with T, and we kind of understand that if A has to be positive, then T, based on example, then T should be bigger than F1, then of course it's pulling stronger, but at the same token, F2 should be greater than T. Then this is more than that, and this is all accelerating. All accelerating, and all is under the tension. We can discuss the third case, for example, when F1 equal F2. In this case, acceleration would be 0. And again, that makes a lot of sense. If one force that way, this force that way, it's all under tension, and it's not moving anywhere, and acceleration should be 0, because what is pushing the system to the right is equal to what is pushing the system to the left. They balance, no acceleration. What will happen with T in that case? T in that case would be M1 F1 plus M2 F1, and here would be M1 plus M2. I am just putting F1, it's the same like F2, and I am putting it here. Instead of 2, I am putting F1, and then I am factoring it out, and I have F1, because this is M1 plus M2, and the same bracket on the bottom, they cancelled up, and T equal F1, and again that all makes a lot of sense, because T is tension, it equal to F1, this body is not moving, the same tension here, it equal to F2, which is the same like F1, so everything is in balance, and nobody moves, accelerates nowhere. So that's all good, but let's expand our analysis, because the critical word that I said, that the rope has to be on the tension. That the rope has to be on the tension. Let's imagine that we have F1, and F1 would be directed here, that way. So we actually will have F2, we have the rope, we have T, and we have T, and we have this body, and this body is pushed in that direction, F1, whatever little force it is. Like if it's no force, F1 equals 0, that would be F2 applied to moving those two masses. But if I'm helping a little bit with F1, then this would be minus minus, because F1 would be directed here, and this would be a little bit bigger than F2. And acceleration would be a little bit bigger than this F2. Like if it's F1 equals 0, then acceleration is F2 divided over total mass. But if F1 is a little bit negative, very small, then this would be a little bit bigger, and acceleration, of course it makes sense, because I'm pushing from here, my tangent goes down a little bit. My tangent goes down, and doesn't matter, the tangent goes down, this tangent goes down, this balance increases acceleration a little bit more out of balance, and it's all moving a little bit, or we can say this force and this force are working a little bit in unison. What very important that we should always have that the T, the tangent is always bigger than 0. Tangent cannot be negative. If we can interpret acceleration and forces and this direction with positive and negative, we cannot interpret this with T, because when we were writing our formulas, we always assumed that tangent acting on this body is directed here, and tangent that acts on this body is directed here, so we put the sign accordingly. We cannot suddenly come to this formula and receive, for example, the negative tangent. What, for example, would be if F1 equals minus F2? So it's the same force that pushes it here. Then our tangent would be M1, and instead F1 equals minus Ft. So M1 F2, and then plus M2 multiplied by F1, but F1 is minus F2, over this sum M1 plus M2. And it would be the same like T equals F2 factored M1 minus M2 divided over M1 plus M2. And very important that T in that case is positive. That means T has to be positive. That means this thing has to be positive. That means M1 minus M2 has to be positive. That means, I'm writing upwards, that M2 should be less than M1. And again, that has a lot of sense, because if we're pulling here with two identical forces, two forces, this and the same force here, right? The thing is that this thing cannot accelerate faster than that. This mass has to be smaller. Then this force pushes mass and creates big acceleration than this mass. Forget about rope, for example, for 1 second. If these forces are the same and this mass is smaller, then yes, smaller mass, big acceleration, A2, and this tries to go with a small acceleration, and the rope immediately tangents. And as the rope tangents, the tangent force helps this accelerate a little bit more, and at the same token, this force helps this to go a little bit less. And they kinda becomes the same, and the system becomes under the tension. But if it so happens that this mass 2 is very big, for example 10, and this mass is very small, for example 1, then this acceleration will be 10 times force is the same. Forget about rope for 1 second. Then this acceleration would be 1/10 of that acceleration. That means this will accelerate very fast relative to this, and the rope become like this, limp. So what I'm trying to say is that I like when the formula suggests, when you write the formula in characters, not in numbers, and formula suggests some solutions that are not obvious, that, for example, negative, what happens if one is bigger than another, what happens if they are both the same, what happens if one force is equal to 0, all of this. That tangent should be like this tangent bigger than this, but this tangent should be less than that, and then both bodies can move simultaneously with the same acceleration and still the rope under tension. I like this, but you also have to be very careful with some hidden things sometimes. So when you're looking for the sign, be careful. And with the rope, but it is very, very advanced stuff. It's not likely your teacher will ask you. And this discussion is really for guys and girls who want to have advanced understanding. But basically the idea is that when we solve for tangent, and when we plug the number, and God forbid we receive negative number for the tangent, that means we get something wrong. Tangent has to be positive. That's the nature of the rope. Acceleration forces then can be different sign, because it's all the meaning how they directed towards the axis that we choose. In this case, axis is that way. But tangents always, no matter how we will choose the direction, we always choose the tangent that pulls on the body, and it cannot be negative. And basically that's all I wanted to say today. So if you like, I hope you already subscribed, and if you have question or discussion, please put it in the comment. Thank you.